Ja, jag ser till...
It seems there's going to be no shortage of robots willing to work in outer space. This one, Robonaut, is exceptional. Robonaut was designed by engineers at NASA to work outside space vehicles, reducing the time astronauts have to spend on spacewalks. The pressure difference between the inside and the outside of the shuttle means that the astronaut must take time to adjust.
At least two uses of the eyes in Robonaut. On the one hand, we're piping that video directly to a teleoperator, and he's wearing a helmet that has two displays. So whatever Robonaut sees with its eyes are displayed left and right with binocular vision. The most obvious thing for Robonaut, since it's a tool user, is to understand tools, to be able to see tools, to recognize them, ideally to anticipate the needs of an astronaut, to say, okay, he's at the point in the procedure where you normally ask for a wrench. I better get that wrench ready.
And like any self-respecting handyman, Robonaut is pretty good with his hands. This was a huge achievement from a design point of view.
The human hand is probably one of the most incredible machines anybody is ever going to have association with.
Will robots take over the world? Yes, and the revolution is set for a week from Saturday. Okay, I'm kidding. It's this Thursday. Kidding again. As much as science fiction movies might make you think we're ready to rule the world, we still depend on you for everything. Power, design, manufacturing, programming, a whole bag of tricks. And for every job that a robot takes over from a human, there are other human jobs created. Someone has to build, program, supervise, and maintain the amazing machines that are robots. How does a robot think? One of the things that makes a robot different from a simpler machine is that it is controlled in some way by a computer. It takes in information from sensors that help it see, and then follows a program to decide what to do. These programs are called algorithms. For instance, some robots that carry mail around a large building have to figure out a path around people. Or a robot that sorts fruit on a conveyor belt would have to decide if a banana is too green for its age. And some robots don't have to think at all. They just do the same precise motion over and over again. If I only had a brain.
I'm Trevor Blackwell, CEO of AnyBots. We're a Silicon Valley company with a mission to change the way people work together over distances. It's so important to be part of the team at the office. We want to give people a way of interacting with people and really being part of a remote team without having to fly. It's like a video conference system, but you can drive it around, so it goes where you tell it to. You can be somewhere instantly. If an issue comes up in the factory or the warehouse, you can be there in seconds. It's designed to feel smooth, comfortable, and safe. When someone logs into it, it announces itself. It moves when you tell it to via the keyboard. It's useful for anyone who needs to work with other people across town or across the world. I really care about making people be part of the team they're in.
How do you think about the eye movement?
I think the eye movements are wonderful.
But
And the lip movement. But I think that
no,
you see there's no effectiveness though. Yeah, because that's not natural. So your eyes go. Just smooth eye movements and then they stop, completely stop, and we don't do that.
Now we are using air actuator. The air actuator is also quick. But if we replace with the DC servo motors, that will be
But then you said they make noise. So this is all compressors, all air, because I don't hear any noise.
No.
I don't hear any noise.
This room is noisy.
So over there is the noise, but not here.
No.
Oh, I see. Oh, there is noise, but I can't hear it because of the background.
脳科学や認知科学などの人間そのものを研究する科学と融合させ、
Very
人
quiet.
間を真似して作
Hear
る
the
人
next.
間のような
But
自然な
every 2
存在や
years I need to
人間
replace.
のように近づく
American
こと
version.
などを
American
した研究
So
を
when will yours
大
be
学で
finished?
行ってい
Your
ま
master?
す。
That will be appeared the next
これ
February.
で自己紹介を終わら
If
せ
you come
て
to
いた
the
だき
next
ます。
February, you will see the control in China.
That's good. That's a good plan. 20 to go. Okay. So maybe.
So today's manufacturing robots are big and stiff. They're unsafe for people to be around. They're engineered to be precise and repeatable, not adaptable. And they only operate in very structured environments. And normal workers can't touch them. They can't get near them. They're specially engineered to do the same thing again and again. So it's not cost effective to build stuff for Walmart where you're changing the product every 3 months or every 6 months, because the setup time for the line might be a year. Now, most of you in the audience are too young to remember this, but back in the old days, ordinary people couldn't touch computers. They were hidden away behind glass walls, and special engineers dealt with them, and you just got a fan-fold printout on your desk, and if you didn't like the numbers you were getting, it had to go through systems analysis and programming and punch card operators and computer operators, and if you were lucky, a few weeks later, you'd get a new series of numbers coming along. But then there was the revolution with the PC, and now ordinary people can touch computers, and so we've just seen an amazing abundance of new ways of using computers, unthought of 30 years ago, because ordinary people get to touch them all the time. Today, our robots in factories, ordinary people can't touch them. What if ordinary people could touch robots? What if ordinary people got to interact with them and use them? And we're starting to see that, in fact, not in industrial robots, but in other places. So top left there is the Da Vinci system from Intuitive Surgical, just down the peninsula here, which ordinary people, surgeons, if you call surgeons ordinary people, are using those robots to operate on people. On the top right, well, the rest of the slide is robots from one of my companies, iRobot, over 4 million robots in people's homes where you don't program them, ordinary people press the clean button and they clean. Across the bottom there, robots in Iraq and Afghanistan. There were 0 ground robots in the US military in the year 2002. There's now over 10,000 of them. There's going to be hundreds of thousands before too long. So now ordinary 19-year-old kids who've off in Iraq are given a robot to use to deal with improvised explosive devices, and they're using them and they're saving lives for the soldiers. So ordinary people are now able to touch robots. So we're able to do that in the lab now. And as I see everything happening here with the makers, it's the stuff that people are doing here is just a very few years. What was really hard to do, was really hard to do in the lab. So I think there's great opportunities here to up our game on what we're going to build our robots to do, and ultimately then help in factories.
A robot took to the catwalk. The multi-million-dollar HRP-4C was developed by Japan's National Institute of Advanced Industrial Science and Technology. And that's a look back at the biggest robot news of 2009. We're going to leave you with the HRP-4C singing with the assistance of Yamaha's Vocaloid software at this year's CTEC show. Stay with IDG for the latest robot news throughout 2010.
空を教
か